everyone, I'm Dr Becky Appleton, and in this presentation I'll be talking you through different sampling techniques in research. Imagine that you're doing a research study where you want to see whether a new lifestyle program can prevent type 2 diabetes in adults. How would you decide who to test this lifestyle program on? Would we need to include every adult in the country to know if it's effective in preventing type 2 diabetes? This clearly wouldn't be feasible. Therefore, we need to create a sample of the whole population to use in our research. Your sampling strategy is important, as this can help inform the validity of your research findings. If we only include adults from one wealthy neighbourhood, we might get results that don't apply to the whole population. This would be a biased sample. The way we select our sample determines how well our results apply to the real world. If you read about sampling, you may come across some of these terms on the left-hand side of this table, and they can be a little confusing, so I thought I'd start off by going through what we mean by these particular terms and how we define them or apply them in our own research. So thinking back to the example I used on the previous slide around a lifestyle intervention for type 2 diabetes. This helps us identify our target population. The definition of this is the whole group that we want to be able to draw conclusions about. In this case, all adults in the UK at risk of type 2 diabetes. However, as mentioned, it's not feasible to look at your whole target population, and it might not even be that everyone within this population is accessible to you to include in research. Therefore, your accessible population refers to the group that you can realistically reach, so you might be able to include them in a study. An example in this case is therefore adults registered with NHS GP practices. This is still going to be far too large for us to use for our research project. Therefore, we want to create a sample, and these are the people who we actually include in our study. An example in this case might be 500 adults from 10 GP practices in the UK. Your sampling frame refers to the list that you draw the sample from. So again, sticking with this example, this would be patient records from participating GP practices. So you may start off by recruiting 10 GP practices in different parts of the country, encompassing both urban and rural locations, and areas with higher and lower levels of deprivation. And this all helps to ensure you have a representative sample to begin with. Finally, your sampling method involves choosing who is included in your sample. And you could do this through different methods. For example, random sampling, where everyone is just randomly picked from a patient list. Or you could stratify your sample according to certain characteristics, like age or sex. And I'll talk through this more as we go through this presentation. This slide shows an overview of different sampling methods you could choose from. And I've divided these into two main categories: probability or non-probability sampling. In probability sampling, all subjects in your target population have an equal chance to be selected in the sample. In non-probability sampling methods, however, the sample population is selected in a non-systematic process, meaning there is likely not to be an equal chance for each subject in the target population to be included. In general, samples which are selected using probability sampling methods are more representative of the target population. But whether you choose to do a probability or non-probability sampling method may depend on the type of research you're conducting. Examples of probability sampling include things like simple random sampling, where it's just random number generator and it will identify, say, 200 randomly selected participants. You often use a computer program to do this. Another example is stratified random sampling, where this is still a random sample, but you want to make sure that you've got certain characteristics stratified within your sample. So you would have a random number of people who are, for example, under 40, and then another random sample of people who are over 40 in your sample. This ensures that key characteristics are represented in your final sample for your research. You may do something such as interval or systematic sampling. So this is where you would choose, say, every 10th person from a patient list to receive a link to fill out a survey. Cluster random sampling is similar to the other approaches, but this involves dividing your larger population into smaller groups to randomly sample from. So this could be certain neighbourhoods, certain GP practices, or certain schools. Moving on to non-probability sampling methods. And the main methods here are snowball sampling, which is where you may identify one person and then use them or their contacts to try and find other participants. This can be useful if you're studying a rare condition, for example, and you might want to speak to parents of children who have this rare condition, and actually just looking at patient records from one practice or one hospital might not be enough. So you might use a snowball sampling method where you ask certain patients, certain clinicians, if they can pass on study information. Another example of non-probability sampling is convenience sampling. So this is where you simply ask people to take part in your study as you see them. So this could be everyone that comes into your clinic on a certain day. You give them a leaflet which invites them to take part in your project. This is probably the easiest and simplest sampling method, although depending on your research question, it may introduce bias. So it's important to think this through clearly before going ahead with this approach. The sampling approaches I've just spoken about tend to be used if you're conducting a quantitative piece of research. However, sampling in qualitative research might use a slightly different approach. This is because this focuses on understanding meaning and people's experiences, and therefore needs a relevant and really information-rich sample. So this might need to be people who've experienced a particular intervention or who live with a particular condition. There is also generally a much smaller sample size in qualitative research, generally up to about 20 participants for most qualitative studies. Commonly used sampling approaches include purposive sampling and theoretical sampling. I'll now go through these in a bit more detail. So, purposive sampling is a method where participants are deliberately selected because they're likely to provide really rich, relevant, and detailed information about a research topic. Researchers choose participants on purpose because of what they know or what they have experienced. Similarly to my previous example, this could involve particularly choosing commissioners or service managers, people that have a particular role who you know will know certain information, for example, around the impacts of the introduction of a new policy or a new treatment, for example. In contrast, theoretical sampling is a more flexible sampling strategy where data collection and analysis happen at the same time. Decisions about who to sample next are shaped by your ongoing data analysis, and this is based on perhaps emerging concepts or theories which you're identifying as you start to analyse your data. An example of this is where you might find that somebody has mentioned why a particular treatment might work or not work in a particular setting, but you want to find out more about it. So you might try and recruit people who can fill that gap in your data. This approach is used to develop and refine a theory, not just to describe people's experiences. Here is an example of how this might work in a qualitative project with a research question of what are the key challenges faced by people when managing daily life with long COVID? So you want to use purposive sampling here, where you're deliberately selecting people who are likely to have rich insights. There are 4 main steps, starting off with defining your inclusion criteria. How will you define long COVID? In this case, I've gone with having experienced long COVID symptoms for more than 12 weeks. I've chosen this 12-week period because you want to make sure people will have enough to say. They'll have lived with this condition for a particular length of time, which means that they'll have valuable insights which can help answer your research question. This research question is a little vague and just says, what do people face? But in my inclusion criteria, I've defined this as adults over the age of 18. Another inclusion criteria is they must be able to take part in an interview. So this could be online or face-to-face, perhaps depending on which approach is best for them. You then want to identify potentially relevant subgroups. To explore different experiences, the researcher might purposely recruit people from certain groups. So those with more recent diagnoses versus longer diagnoses, people who have or have not returned to work, and people from different genders, ethnicities, or age groups, etc. This means that you're likely to get different experiences and different information across your sample, which then increases the likelihood that your findings will apply to the general population as a whole. During your recruitment period, you then try to make sure that you are recruiting people from all of these relevant subgroups. You might be able to tweak your recruitment strategy to fulfill underrepresented groups. So, for example, by recruiting from GP practices which have a higher proportion of patients from minoritized ethnic groups. If when you get halfway through your sampling and recruitment, you realise that actually you haven't been able to include any participants from ethnic minorities so far. I'll now take you through another example using a quantitative research question. In this case, does a new lifestyle intervention reduce HbA1c levels in adults at risk of type 2 diabetes? I've chosen to do a stratified sampling approach, as certain characteristics, such as age or sex, might influence how well the intervention works. Similar to my previous example, we want to start off with defining our inclusion criteria. And this can link in with our target population. So in this case, I will define adults as people aged between 18 and 65 who live in the UK, who are at high risk of type 2 diabetes. The next step involves choosing our stratification variables, so the demographic characteristics we want to make sure are represented within our population. And in this case, I want to make sure each major key subgroup is represented, so including things like I've already mentioned age and sex, but also ethnicity and perhaps socioeconomic status. I think around 4 or 5 characteristics can work here really well. You then need to create your strata, and this means dividing your population into subgroups based on the characteristics that are relevant to your research question, and then working out the proportion needed within your total sample based on proportions in the overall target population. So if you think of everybody in the UK who is at risk of developing type 2 diabetes. This is a made-up figure, but you might know from your target population that around 5% of men aged between 50 and 59 are at risk of developing type 2 diabetes. Therefore, you want to make sure that 5% of your total sample are men in this age bracket. The final step is recruitment. So you might want to compile a list, for example, from GP records, and use a random number generator to select participants. So everybody in that stratum has an equal chance of being selected. This has been a fairly brief review of different sampling methods. So I've included a few different papers here, which I think go into a bit more detail if you'd like to find out any more information about the sampling techniques or methods that I've spoken about in today's presentation. And finally, you can see the direct link on screen to the catalogue hosted on NHS's Learning Hub platform. Registration is free, and if you have an NHS email, you will have free access to both the Learning Hub as a whole and the WE-R NHS catalogue resources. We have links to podcasts, videos, and journal articles on a range of topics related to education and workforce research. WE-R NHS is on YouTube, and we also have a regular e-newsletter. Thanks very much for watching.